Right, guys. So we have finally, at least very roughly, designed the base. Uh, but I want to sort of interject a software into this now so that we can formalize more about how we can make this faster, which is FreeCAD. And FreeCAD is, well, a 3D modeling software that I've been using. It is surprisingly powerful, even though it does not have the world's best user interface. Uh, it's nothing like Blender, but it is still pretty good for hobby 3D printing, I feel. And that's what we're doing. So I will, year onwards, be giving a short tutorial on how to actually use FreeCAD because I feel like that's the best thing to do. So anyways, when you open FreeCAD, it's open source. You can download it. You can get it from the internet. And yeah, you just go create new. And you start with part design. This is all very obvious. Nothing. When you go create body, create sketch. This gives you 3 planes. So XZ plane, XY plane, YZ plane. Now, since our base is going to be this flat thing, and it's going to sit like this, we expect this to be on the XY plane. So we will choose the XY plane. But before you do that, we actually have these options of like actually tilting our diagram in all kinds of funny ways. Yeah, just something someone can do, I guess. Anyways, so once we start doing this, there's lots of tools here, far too many, honestly. So I won't go through all of them, just the ones that are useful. I actually don't know what all of them do. I know maybe like 10. So we'll start with a rectangle because that's what we need to do. Now, if you put a rectangle in a space, a 2-dimensional space, you need to define 3 things. You need to define its length, its width, and where exactly it is placed in that space. So the distance from the origin, right? So you need 3 things. These are called constraints. And these are important when you're using CAD. So we just made a rectangle, but now we'll start placing constraints. So this places what's called a horizontal constraint. So you can select this edge and this edge, and then it allows you to give a horizontal constraint. Now if you look at the diagram, this is 15 plus 15 plus 16. Now it does the math for you automatically. You see how I just made it 98. I don't know if that's visible. Yeah, it's not, maybe. But anyways, that's 98 millimeters. So it did that automatically. You can again do this for vertical side. Sorry, not like this. Just like this, and this was 15 plus 15 plus 52. That is 15 plus 15 plus 52. Right. That is good. And now we need to constrain it to the center. So for that, we can place a vertical constraint. This is going to be whatever is 15 plus 15 plus 52. If you do that, that's 82 divided by 2. So it centers this, and you then do this horizontally as well. This is 98 by 2. And you see that it's actually turned green, which is wonderful because this means we finally placed it. Right. This means the constraints are satisfied, basically. So once this happens, you can close the task. And if you go into model, you'll see that we can now actually, see our XY plot. Yeah. And you can actually use these keys 0, 1, 2, 3, 4, 5 to change your view. That's exactly what I was doing right now. And now you just have to go to pad. This makes it, this sort of extrudes it or adds padding, whatever. And we just want 4 millimeters. So we'll do just that. Yeah, so we have now finally a rectangle. And this is exciting. Yeah. Right, so I did make some engineering drawings to now build onto the base. So far in our CAD software, we have only built this rectangle. And now we need to build these sections, right? So this is the arm slot. I'll quickly explain this drawing. So as you remember from the last time, we need to set constraints in CAD. So, and we usually set those constraints from the origin. We can set relative constraints, that is one part constrained against the other, but we'll be setting all the constraints from the origin. Oh, so I did calculate some distances. These are from the last section where we actually discussed, I looked at the data sheets, and then I made some diagrams here, some requirements, like this needs to be 5 millimeter, the angle is 45 degrees. This will be a cutout circle here so that we can allow wires to come out of this place, because this part would be filled by the servo. Right. So I'll quickly explain some of the constructions. I won't be able to explain all of them, but I placed this line here so that I would be able to easily calculate HEFG. And this is really basic maths. It's not really that hard. We know that the servo from the data sheet needs 12.5 millimeters across. So since GF is 12.5, we know that this and this would be the same, since this is a isosceles triangle. And we can then apply some Pythagorean theorem. And all the calculations that I'm performing, I'm doing those on my scientific calculator. The thing is, I'm only taking 2 decimal places. I think it doesn't make sense to take any more decimals than that. So I'm rounding all the numbers that I take to 2 decimal places. So I've performed some calculations. I will not justify all of them. I'll just put these out here so you can have a look for yourself if you want to. This was the first one. This is the second sheet of calculations. Yeah. Which is where we set constraints on these. This took me a long time last night. It took a few hours at least. And I did complete all the calculations. They're all to 2 decimal places. I don't think any more precision than that is necessary. And once we've done this for one side, it's very simple to do it for the next 3, because it's the same as a rectangle would be symmetrical on the 4 sides. And the final ones are for the drill holes, where these 4 are the holes as we talked about in the Arduino. It's this one, maybe point to the pen, this one, that one, this one, and that one. And I've made these right here. Also the holes have a diameter of 3.2 millimeters. It's all again given the data sheet. And this is the origin. So I again calculated the distances from there. Again, these are very simple calculations. We're just dividing by 2 or calculating linear gaps. Nothing too complex. Yeah.